Alright, this is the first introduction to chapter 6, DC current. Basically in this chapter we're going to deal with many different kind of electrical circuit. And in order to understand the different type of problem, there's a couple of notation we need to take into account as well as some assumption. So first, let's have a look at the typical circuit. So I have a circuit over here and it has 4 components that we will see over and over again in this chapter and even in chapter 7. So the first component is the battery or the power source over here. So it has a large bar and a smaller bar. The large bar is the positive side, the smaller bar is the negative side. We have also a switch. Now if the switch is open like this, the current is not able to flow in the circuit, all right? When the switch is closed, the current is able to pass in the circuit. We also have a resistor. Often we will use the notation R for the resistance, V for the power source, and S for the switch. We have also this symbol over here, which is the ground, often which is denoted G and D. And the ground is where we consider the voltage to be at 0. Now note, when we are calculating the voltage between 2 points, the only thing we can determine for sure is the difference in voltage between 2 points. So often we set our ground to be 0, and actually if we are talking about Earth, for example, there are some extra electron on Earth, so there is an electric field on the ground. But nonetheless, we still set that point to 0 and measure everything else with respect to that point. All right? There's a couple of assumptions regarding the circuit that we need to take into consideration. So first, the resistance of the wire is equal to the 0. Now that's a bit different than what we did in chapter 5. In chapter 5, we calculated the resistance of each wire of different material. But here, the wire has a resistance of 0. And when I'm talking about the wire, I'm talking about this section connecting 2 components, all right? So there's no voltage drop in the wire. Second point, the total charge remains constant. So there's no charge added in the circuit or no charge removed. Now, a point that's creating some confusion, especially when you're first dealing with circuit, is the battery itself is not adding charge. It's more like a pump. A pump in a water, let's say in the water machinery, will be pumping water, but it will not be adding water. Same logic with the battery. It's giving energy to the electron, to the charge themselves, but it is not adding extra charge. The third assumption, Ohm's law is always true. So in this chapter, Ohm's law is always true, and actually in the complete semester, Ohm's law is always true when we deal with electric circuit, all right? So we need to keep in mind these assumptions. We will see in a future video, there's a lot of consequence when we apply these assumptions that will be very helpful in solving some of the problem, all right? So in the next video, we are going to tackle circuit in series, parallel circuit, and yeah, so let's go into the next video.